Imagine a world where a simple scratch could kill you. Sounds like dystopian fiction, doesn't it? Yet this could be our reality if we don't address the invisible threat of antimicrobial resistance. Antimicrobial resistance, or AMR, is like a ticking time bomb. It occurs when microorganisms, such as bacteria, viruses, fungi, and parasites, change in ways that render the medications used to cure the infections they cause ineffective. When the microbes become resistant to most antimicrobials, they are often referred to as superbugs. This is a significant concern because a resistance to antimicrobials makes the standard treatments ineffective, allowing infections to persist and spread. So, how did we get here? The answer is antibiotics. These life-saving drugs have been overused and misused in humans and animals, often given out for illnesses where they have no effect. Each time we use antibiotics, sensitive bacteria are killed, but resistant germs may be left to grow and multiply. These resistant bacteria can then spread and take over. Furthermore, they can pass along their resistance to other bacteria. This means the misuse of antibiotics can lead to more superbugs that are resistant to all antibiotics. And that is a terrifying prospect. Imagine pneumonia, tuberculosis, and gonorrhea, once easily treatable, becoming potential death sentences. The World Health Organization calls antimicrobial resistance one of the top 10 global public health threats facing humanity. It's like a slow-moving earthquake that's ready to split the ground beneath our feet, turning minor infections into potential killers. But it's not all doom and gloom. We can turn the tide against antimicrobial resistance by understanding it, by respecting the power of antibiotics, by investing in scientific research, and by implementing effective policies and practices. So let's not let this invisible threat become a visible catastrophe. It's a battle of evolution, and currently the microbes seem to be winning. But with knowledge, action, and vigilance, we can fight back. After all, our lives and the lives of future generations are hanging in the balance. So, how exactly do these tiny microbes outsmart our most potent drugs? Well, bacteria, much like any living organism, are driven by an innate desire to survive, and they have a few tricks up their microscopic sleeves to do so. One way bacteria resist antibiotics is by altering their own structure. The antibiotic is designed to target a specific part of the bacterium, but if the bacterium changes that part, the antibiotic can no longer do its job. Imagine it like trying to unlock a door with a key, but the lock has been changed. The key doesn't work anymore, right? That's the same principle here. The antibiotic, or the key, is rendered useless because the bacteria have changed their lock. But bacteria don't stop there. They also have the ability to pump out the antibiotics that do manage to get inside them. It's like having a built-in ejection seat for unwanted intruders. The antibiotic enters the bacterium recognizes it as a threat, and then promptly ejects it before it can cause any harm. Now let's talk about plasmids. These are small, circular pieces of DNA that exist separately from the bacterium's main DNA. Plasmids often carry genes that provide resistance to antibiotics. The real kicker: they can be shared between bacteria. This sharing of plasmids, known as horizontal gene transfer, is a primary way that resistance spreads rapidly among bacterial populations. Imagine you're in an office and everyone is sharing the same box of tissues. If one person has a cold, it won't be long before everyone else catches it too. That's how quickly and efficiently resistance can spread among bacteria. This is the science behind antimicrobial resistance. It's a constant battle of wits, a never-ending game of cat and mouse, where we develop new drugs and bacteria evolve new ways to resist them. Nature is an efficient engineer, isn't it? Even the smallest creatures can adapt and thrive against seemingly insurmountable odds. But it's not all doom and gloom, right? Surely we're not on the verge of a post-antibiotic era? Well, let's take a moment to examine the global impact of antimicrobial resistance. Imagine for a moment a world where minor infections could once again become deadly. A world where routine surgeries carry a high risk of fatal infections. This isn't some dystopian fiction, but a grim reality we could face if antimicrobial resistance continues to grow at its current rate. The World Health Organization warns that antimicrobial resistance is one of the top 10 global public health threats facing humanity. Every year, nearly 700,000 people worldwide lose their lives to drug-resistant diseases. If we don't act now, this number could skyrocket to 10 million annually by the middle of the century. In economic terms, the impact of antimicrobial resistance is staggering. It's estimated that by 2050, the global economy could lose a whopping $100 trillion because of it. This figure is more than 1.5 times the entire global economy today. But it's not just about the numbers. It's about the human stories behind these statistics. It's about the mother who can't protect her newborn from a simple infection, or the farmer who loses his livestock to a disease that was once easily treatable. It's about the cancer patient whose treatment is compromised because the drugs used to prevent infections no longer work. The consequences of antimicrobial resistance extend beyond human health. They reach into our food systems, our economies, and our very way of life. Antimicrobial resistance is a silent crisis, one that grows in the shadows, often unnoticed until it's too late. But it's a crisis we can't afford to ignore. We are standing at the precipice of a post-antibiotic era, where the medical advances of the past century could be undone. The stakes are high and the clock is ticking. So are we just sitting ducks waiting for the microbial apocalypse? You might wonder. Well, let's shift gears and delve into the current strategies we're employing to combat this invisible enemy, antimicrobial resistance. First and foremost, there's an ongoing quest for new drugs. Our scientists are burning the midnight oil, exploring every nook and cranny of the microbial world and beyond for potential life-saving compounds. Picture them like detectives scanning through the microbial universe, seeking out chemical weapons to fight back against these drug-resistant bacteria. This isn't just about finding new antibiotics, though. It's about reimagining the whole concept of antibiotics. Think about the difference between a sledgehammer and a sniper rifle. Traditional antibiotics are like sledgehammers. They wipe out bacteria wholesale. But what if we could develop drugs that are more like sniper rifles, targeting only the harmful bacteria and leaving the beneficial ones unharmed? But it's not just about the drugs. We also need to promote responsible antibiotic use. Overuse and misuse of antibiotics have been major contributors to the rise of resistance. It's like giving our enemies a sneak peek at our battle plans. We need to be smarter about when and how we use these precious resources. This includes not just doctors and patients, but also farmers and veterinarians, as a significant amount of antibiotics are used in agriculture. There's also a need for global cooperation. Antimicrobial resistance doesn't respect borders. A superbug that emerges in one part of the world can quickly spread to others, so we need a coordinated worldwide response. We need to share information, resources, and strategies to ensure that we're all fighting this battle together, not in isolation. And finally, we need to invest in education and awareness. Everyone needs to understand the gravity of this issue and the role they can play in combating it. From washing hands to completing prescribed courses of antibiotics, every little action counts. We're in a race against evolution, and we can't afford to lose. Because if we do, we might find ourselves back in a world where a simple cut could be deadly. But with ingenuity, cooperation, and determination, we can turn the tide against this invisible enemy. So, what can we do to turn the tide in this microscopic war? We've journeyed together through the invisible threat of antimicrobial resistance, unraveled the complexities of its science, witnessed its global impact, and observed how we're fighting back. But our journey doesn't end here. It's time for us to reflect, to understand, and to act. We've seen how the overuse and misuse of antibiotics have given rise to superbugs, microbes resistant to almost every weapon in our medicinal arsenal. This isn't just a problem for the scientists in their labs or the doctors in their clinics. It's a problem for every single one of us. The antibiotics that once saved lives are losing their power, and it's our responsibility to slow down this process. So, what can we do? Well, the answer lies in our everyday actions. It starts with understanding that antibiotics aren't a cure-all. They don't work against viruses like the common cold or the flu. Using them unnecessarily only gives microbes more opportunities to evolve and resist. Next, when we do need antibiotics, it's crucial to take them as prescribed. Not finishing a course or taking them irregularly can leave some bacteria alive, allowing them to adapt and resist future treatments. It's also essential to prevent infections from occurring in the first place. Simple habits like washing our hands regularly, keeping our vaccinations up to date, and practicing safe sex can reduce our reliance on antibiotics. Finally, we can help by spreading awareness. Talk to your friends, your family, your colleagues about antimicrobial resistance. Share the knowledge, ignite the conversation, and inspire action. Every step we take, no matter how small, contributes to a larger global effort against this invisible threat. It's a ripple effect, where one informed decision can lead to a cascade of others. Every action counts. Remember, we're not just fighting for ourselves, but for future generations as well.